Welcome to Chapter 9. This is Systems of Equations in Two Variables, Day 1. A lot of this, I hope, is going to be an Algebra 1 review. I hope that you have seen this before because I'm going to go through it. If I go through it a bit quickly, it's because I'm assuming that you've seen it once before, and this is going to be kind of a refresher. If it's not, then feel free to email me with any questions you might have or something like that, but let's just go through it. So a system of equations is when you kind of consider two equations together at the same time. This book will sometimes call it a conjunction, but usually it's called a systems of equations. And the first thing we want to do is make sure we know if we have an answer, how do we check to make sure that it actually is an answer? Basically what you do is you just plug them back in. Like if you think that the negative 3 and 2 are the values that will make both of these true at the same time, you can just plug them in. Negative 3 would be the x value and 2 would be the y value. Check it, and yes, it works for both the top equation and the bottom equation, so therefore it does work for the overall system. If it only works for one of them and not the other, then it's not necessarily considered a solution. For example, 4, 0 will work as a solution for only the top equation but not the bottom equation, so you get basically you get a yes and a no, so the overall answer is no for the entire system. It's got to be a solution for both. You can see right there. So check this out. Which of these is a solution to the system of equation? Well, we can see that if you try and plug in 3, negative 1, you don't get 11, so therefore it's not a solution to the system. But if you try 4, 7, it works for both, as you can see here. It's a solution of both. So now that we know how to check our solutions, the big question is, how do we arrive at the solutions in the first place? There's a couple different ways of doing it that they usually teach in Algebra 1, and one of the first ways is solving it by graphing both. The big idea here is that solutions of equations, and even solutions to systems of equations, are going to be represented graphically by intersections. I need to switch the order of these words around. The intersections that you find on graphs are going to be represented by solutions. So I'll just flash forward to my big point, is that here, if you graph both lines, then wherever they intersect, that's going to be the solution. We already checked it up here, 4, 7. It's the same example, so you can see it works. Let me show you how we get that. There's a ton of ways to graph lines, and one way is to solve for y. Bring the x over to the other side by subtracting both sides by x. Bring say the 5 over to the 3x and the y over the other side, and basically go equation, table, graph. You got an equation, make a table, use a table to make a graph. Notice that if you happen to be so lucky as to choose the actual x value, this 4 right here, and the output is 7, you see that it's the same values on the table. Same values on the table, same point on the graph, there's the intersection, and it is the solution to the system of equations as well, 4, 7. So if you can graph it, then you can solve systems of equations. So anything that's easily graphable or graphable by you, this would be one way to do it. Another way to do it is the substitution method. Basically, you can solve for one variable and then substitute into the unused equation. What I mean is, what I'm seeing right here is that I can get y easily by itself. You have basically 4 options. You can choose this x or this y or this x or this y. I'm going to choose this particular y right here and solve it for y. Solve the equation for y. So subtracting x from both sides, you get y is equal to 11 minus x. And now I'm going to use this expression in the other equation that I have not yet used. I'm going to rewrite this whole thing, 3x minus y equals 5, down here, and instead of writing y, I'm going to write 11 minus x, which is what y is equal to anyway. That's what this tells me. So we have 3x minus 11, the quantity 11 minus x. Notice I'm using parentheses. I think it's a really good habit to use parentheses because even if you don't necessarily need them, it's good to be able to read it and look at it and know that, oh yeah, this is where the substitution got made. Even this, it's definitely required algebraically because there's a subtraction here, and the next step is going to be to distribute the subtraction. But even if there weren't a subtraction, I still think it's a good idea just to be in the habit to visually see what you're doing and to be able to help you check your own work. So it's something to do. Good mathematics studentship even if it's not algebraically required. In any case, you can combine like terms, add the 11 to both sides, divide both sides by 4, and you get x equals 4, as predicted up here, x equals 4. It's going to be the same solution because it's the same system to begin with. But in order to find out what the y value is, you can take that value of 4 and plug it into any one of these equations up top, assuming they're all true, which if they're algebraically manipulated well, then they will be true. So x equals 4, I'm going to plug it into up here, y equals 11 minus x, y equals 11 minus 4. And do the subtraction, you get 7, and then there it is, 4 comma 7. Let's do the same thing again here. You've got these if you're going to do substitution, you've got 4 options: this x, this y, this x, this y. I think the easiest to isolate is, or to solve the equation for, would be this y right here. So in order to do that, you have to subtract 2x from both sides, and you get y is equal to 6 minus 2x. And then I'm going to use this information in the other unused equation. What does y equal? It equals 6 minus 2x. So therefore, I'm going to sub it in right here for this y. I'm going to rewrite the entire equation one more time, and instead of the y, I'm going to write what y is equal to. That's 6 minus 2x, and right here, I'll put it in parentheses again. These parentheses are required, but even if they weren't required, I would still just highly recommend putting them in anyway to get in the habit of doing so. Distribute, combine like terms, solve for x, you get x is equal to 4. And if that's true, if x were equal to 4, then you can use this equation to figure out what y is equal to. So you get y is equal to 6 minus 2 times 4, which is a value that you can figure out, and I'd like you to do that right now. Notice that I've been writing my answers, if these are alphabetizable, like if it goes x, y, z, or like if there were, notice that x comma y is easily represented here in this parentheses. Sometimes you'll see a comma b, the values of a and the value of b written as a comma b, or a comma b comma c, or x comma y comma z. That's typically how solutions get represented when we know what these represent in the first place. Because I know 4 is whatever comes first is the x, and whatever comes second is the y. It's alphabetical. Let me give you something that it's not exactly what I saw on the SATs practice test, but it looks very similar. One thing you'll notice is that they're testing you basically on the same exact skill, solving a system of equations, but they're giving you unsimplified versions of the original equation. So check this out. 2x minus 3y, way more simplified if you just move the 3y to the other side. You get 2x equals 3y. And then here, this crazy fraction, way more simplified if you clear the fraction, which you can easily do. 10 is equal to 2 times the quantity, what they used to be on the denominator. And even further, you can divide both sides by 2 to get 5 is equal to 2x plus y. This is like a much more simplified version of the equation that they didn't give you to start with. They gave you something much more complex. I'm going to note that if you wanted to, you could just stop right here and say 2x. I know what 2x is equal to. 2x is equal to 3y. So it'll save a step or two, but it's not necessary and required. But you can do it here, and it makes things go a little faster. If you know 2x is equal to 3y, then you can say 5 is equal to not 2x, but 3y plus y. Solve it, you get y equals 5/4. And of course, don't fear the fraction. These are the right answers. You just have to plow through and make sure that you get it right. And report the fractions as answers. Y equals 5/4. If that's true, then you can plug it into this equation to figure out what x is. This, and then solve, and you get 15/8. Wanted to spend a little bit of time right now dropping you an audio check. It's the Academy Award winner for Best Picture in 1962 was West Side Story, arguably by me the greatest musical ever, and I can give you probably about 10 reasons why that's true. If you disagree, if you think you've got a better musical, then come at me, because you're wrong. We've got here, we're going to talk about some word problems with substitution. So this is going to be big. Make sure you know knowns and unknowns. And here's another tip. Sometimes it's really good to think about things in terms of their total equations. Identify total equations. It's going to come up in a big way down here. Here you have like a total volume. The total is 10 liters, and the total here is 0.2 times 10. 1.2 total liters of, say, alcohol. But I'm getting a little ahead of myself. Let's talk about example 4. An airplane flight. We've seen these before, and I think I've recommended before that you make sure you examine all the variables of both trips in a kind of a table like this. If your big formula that you're going to use twice is d equals rt, then it just forces you to think about each and every single one of these options. The d1, d2, r1, r2, t1, t2. Setting up the box there's nothing magical mathematically required about it, but it's good studentship in that it forces you to think about all these different things. Only once you set up the box and realize that something is missing, like you've got an empty box, is it a cue for you to make sure that you have thought about it and you've got to fill it in with something. Here's example number 4 from the book. An airplane flies the 3,000-mile distance from Los Angeles to New York with a tailwind in 5 hours. On the return trip against the wind, it makes the trip in 6 hours. Find the speed of the plane and the speed of the wind. So it's the same trip, 3,000 miles both times. That's unchanged. The rate is going to be different because there's 2 components. You've got the rate of the plane, which is not changing, but what does change is whether or not the rate of the wind is helping you or hurting you. During trip number 1, it has a tailwind, so your wind is coming to you from the tail, and that means it's pushing you, and it's adding to making you go faster. If you're going faster, then you can see that it takes less time, and that makes sense to me. That's like confirmation that this should be plus. So here, the difference is that on the second trip is that you've got a headwind, and then you're flying against the wind. It's slowing you down, making the whole thing take longer, more time. And so rate of the plane minus rate of W, rate of the wind, is going to be what you have here. And then 5 hours, 6 hours is the time. Notice we've got 2 equations, 2 unknowns. That sounds like it's solvable to me. So writing them all out, you get 3,000 is equal to Rp plus Rw times 5. Just right off the bat, I'm going to divide both sides by 5 to get 600 is equal to this. It's just a simpler version of the equation. You can do the same thing here, and then divide both sides by 6. You get 500 is equal to this simpler version of the equation. Wait a minute. I think what I can do is, if I'm going to use substitution, word problems with substitution, I'm going to pick one of these variables, Rp, Rw, Rp, Rw. One of those 4 options I'm going to solve for, and I think the easiest one to do would be this, Rp, because when you add Rw to both sides, you get that nice happy addition. Rp is equal to 500 plus Rw. And if you know that information, if you know what Rp is equal to, then you can use that in the unused equation. Here, 600 is equal to not Rp, but 500 plus Rw. That's what Rp is equal to. You notice I'm using parentheses here like a good, happy student of mathematics. Even though I don't necessarily algebraically need to, it's still good for me to visually identify what you're substituting, and it helps check to make sure you're doing it right. Then you can subtract 500 from both sides, and then combine the like terms. You get this, divide by both sides by 2, you get 50 miles an hour is equal to the rate of the wind. And that is a reasonable answer for this particular word problem. Now that we know what the rate of the wind is, you can put it back in here, and then you get 500 plus 50 miles per hour. So the rate of the plane is going 550 miles an hour. These are answers that you can double check back in the original, and they do work. At a restaurant, each bowl of chili has 5 grams more protein than the hot dogs. So eat your chili, boys and girls. We need protein here. If 3 bowls of chili and 2 orders of hot dogs have a total of 50 grams of protein, then how many grams of protein does a bowl of chili have? So right off the bat, when I saw this problem, I thought to myself, I need to make sure I identify my unknowns. C is going to be how many grams of protein does a bowl of chili have? I don't know, so I'm going to make it a letter. I'm going to choose a letter from the alphabet, and what I'm looking for is going to be labeled with a C, the number of grams of protein in a bowl. And then H will be the same thing except for hot dogs. So then, therefore, I can write my knowns out. I'm taking these facts and turning them into equations now that I have letters. C is going to be equal to 5 plus H. 5 grams more protein than hot dogs. And then 3 bowls of chili 3 bowls of chili, and 2 hot dogs are going to have a total of 50 grams of protein here. Now that I've written them out, I can see that I can use substitution. C is equal to 5 plus H, so I'm going to rewrite the bottom equation, and instead of writing a C, I'm going to write what C is equal to inside parentheses. 3 times 5 plus H plus 2H is equal to 50. Distributing, combining like terms, subtracting 15 and dividing by 5, you get H is equal to 7 grams of protein in a hot dog. And that will help you take this value, plug it in here, and then instead of C is equal to 5 plus H, we'll do C is equal to 5 plus what H is equal to, and that's 7. That's 12 grams, and that's the answer. Here's a problem straight out of chemistry, and it's solvable only if we write the equations and consider our total equations. Let me show you what I mean. YA is 5% alcohol by volume. Like, if you were to measure out 100 liters of this wine A, 5 of those liters would be straight alcohol by volume. Not by weight, not by mass, not in grams, but by volume. And wine B is 15% alcohol, again by volume. How many liters of each should be mixed in order to get a 10-liter mixture that is 12% alcohol? So looking at what we don't know, how many liters of each, I'm going to represent those with letters. The variable A is going to be how many liters of A you're going to use in this final mix, and B is going to equal how many liters of wine B will be in the final mix. So the final mix we know is going to be 10 liters. This is a total volume equation. Overall, A plus B is going to total up to 10 liters, and that's going to be very helpful. Then the total volume of alcohol in the final mixture is going to be written by this. Here we've got 10 liters of alcohol, but also the grape juice and all the different parts of wine, the tannins and all that, and the flavors that are not alcohol. But here we're writing a total volume strictly by alcohol. How much alcohol is being contributed by wine A? 5%. That's 0.05 written as a decimal. A. And then B is going to be 15%, this right here. And so then in order to make sure that we have 12% alcohol, we know that our final volume, 10 liters times 12%, or 0.12 written as a decimal, is going to be how many liters of alcohol we have. This is also a total, what I'm calling a total equation. Now, if we're going to use substitution to solve for it, then I think you can choose either A or B right here. It doesn't really matter that much. B is equal to 10 minus A. I'm going to take what B is equal to and rewrite it into this equation here. Oh, one thing I forgot to say is that I think it's just a little bit easier to just clear the decimals. So I multiplied all the terms on both sides by 100. So 0.05 becomes 5, 0.15 becomes 15, and all of this becomes 120. This is a little bit easier to work with, and now we're going to take B, what B is equal to, and plug it in. Instead of B, I've written 10 minus A with parentheses. Distributing, combining like terms, and then you get A is equal to 3 liters. We need 3 liters of wine A, and therefore we'll need 7 liters of wine B if we're going to add up to 10 total. So that is 9.11. Welcome to Systems of Equations. That's the first part of your algebra review. I'd like you to start 9A1, do the first problem, and I will see you in class. Just a quick video to show everyone how to find points of intersection from two curves or lines, both on Desmos and on the TI Nspire. So what that might look like here is y, you just type in your equation y equals x squared minus 1, that'd be the first curve, and then let's do a circle, plus y squared is equal to 9, so that's a radius of 3, and you can see there's the points of intersection. Desmos is smart enough to know that students are often looking for points of intersection, so it allows you to just kind of hover and click, and there it is. Doing it on the TI Nspire was a bit more complicated, but it's so I guess I'm a little biased towards Desmos, but let's take a look. So here on the main screen, home screen, you can press on a couple times, you get there, and then I'm going to do Scratchpad B, graph. I'm not going to use the trackpad, as I'm going to avoid trackpad usage just because I think buttons go faster. So B, you can see it says F1, that means your first function if the input is X. So I'm going to do the top one, the parabola. Type in the x squared minus 1. Enter. There it is. Beautiful. Now here, you could try and solve for y and type it in as a function, but actually there's a better way to do that. You can tap menu, and often menu is a great button if you want to, like, it knows the TI Inspire is programmed well enough so that if you want an option or a feature of something, often pressing menu will bring you to the features that you're looking for. I want to do graph entry and edit, so that would be 3. And then I actually don't want to do a function because a circle is not a function. It's a relation. And so I'm press 2 for a relation. You can see it says REL1 XY. So it's expecting x and y to be related in some way. So we get x squared plus y squared equals 9. Enter. And there's the circle. Now, we want to find an intersection. I'll press the menu button, and that would be Analyze Graph. Notice this. We can also find trace options. We can find zooming options, but we can even make a table out of what's going on. But I want to analyze this graph. In what way do I want to analyze? So you can find the zeros. That is whenever a function crosses the x-axis, that's a 0. You can find a minimum or a maximum. Intersection number 4. Now here we are going to have to use the trackpad, I think. So, I'm going to use the arrows right now to draw. Basically, it says, you can see right here, it says first corner, question mark. It's looking for you to make a corner. And so you can use the arrows or you can use the trackpad. I'm going to click, and now it wants to know where the second corner is. So we're going to go over a bit. It's looking for it's looking for kind of a square. And enter. So that dotted line square that you saw right here is, you need to give it help. It can't just find the point of intersection. It doesn't know what you're talking about if you just say, find the point of intersection. You have to give it a square. And then it can zoom in very quickly on the point of intersection that's inside that square. And maybe it's a bit difficult to see right here, but it's the same value that you see right here, negative 1.84. Incidentally, one interesting thing you can do is if you can grab it with a trackpad, you can actually make this bigger. You can drag it bigger or smaller as you see fit. Anyway, that's how you find points of intersection. Have fun. You're welcome. See you in class.